right, so official welcome and mahalo to our ATLT Hicks panel session for 2022 now, and I'm really happy to have a big crowd. Big mahalo to all the reviewers, big mahalo to all our authors, and who really part of our panel to make it so strong now. And also would like to thanks anyone who joining our session right now. So it's going to be recorded, and the link to agenda and also link to our ATLT group on LinkedIn are posted on the chat room, so you can access anytime. And so we plan actually to have each other to have on average 5 minutes for presentation and maybe keep 5 minutes for a question and answer. However, if you feel like you need to go more, so we just have a maybe fewer time for question and answers, but it's okay, because what we'll do is also, while presenters presenting, everyone feel free to post your questions in the chat room, and we just record the chat room, and we can individually send those suggestions or any questions. So that's our plan, and our plan also for you to have your warning signal 5 minutes, just to give you some, give you some notification that it's 5 minutes time. And
That's the sound. That's the sound.
All right, it's gonna be a couple of times. From that, it's up to you whether you keep going or summarize it briefly and then start the session with the question and answers. All right. So, are there any questions before we start? And before I kind of introduce our co-chair cohort, and I'm making sure everyone is. I need to constantly admit people to the registration to the, with the Zoom bombing, you have to be very careful. So I put extra protection by asking people to register. Thanks for going through that extra step, and also have to admit people manually, but just to avoid any kind of additional issues. So I'm hoping nothing's going to happen. We'll see. So thanks again to our cohort of co-chairs. So we have Jim, the one with the bell. So Jim, feel free to wave your hand.
Yeah, aloha, mahalo everybody, aloha.
Great. We have Christian.
Hello.
And Nita Chris is not, I don't think she will be able to join. She's on honeymoon, obviously. And myself, Olga. So thank you very much for being with us. And so after presentation, again, 5 minute presentation and about 5 minutes question and answers, feel free to unmute yourself and just answer questions, or you can post questions on the chat room, and I'll just save all the questions and I can email to each individual authors for the future references. And we also like to encourage everyone to, if you haven't joined ATLT on LinkedIn group, feel free to join it, and authors will post slides so you can have references to it. And that's where I will add our recording video for today's sessions. And also there's, if you scroll down very bottom, there will be recorded sessions from last year, in case if you're interested to go over. It was a very interesting session as well. All right, so our first presenter will be Florian and Sebastian on virtual tutor, combining conversational agents with learning analytics to support formative assessment in online collaborative learning. And so Florian or Sebastian, feel free to share screen and start presentation.
So, hello from my side. I will only just try to allow Zoom to share my screen. Always a bit of hurdle because the tool has some quirks, but I try to do. And
Did we lose Sebastian?
I hear him typing, I think, so I'm looking just.
So here I am.
There you go.
Sorry for that one. Turns out that the company's Mac or the university's Mac has some quirks with that. So without further ado, I represent both of us since Florian has become father like 2 weeks ago and therefore couldn't join us today. But I will present our research. And what we did is we investigated the possibilities of bringing a virtual tutor conversational agent in an online collaborative learning environment, which is nothing new for sure. But our focus was a different one because we wanted the conversational agent to support learning analytics and especially the educators rather than the learners within this scenario. So what was our research questions? We started with the idea that we want to bring up design principles which should be considered when creating such conversational agents for which help to provide formative feedbacks for educators and for learners to allow, organize, and self-reflect their performance. So that was the first one. And the second part, obviously, is when we make an implementation that how do educators and learners assess the benefit of such a virtual tutor based on the design principles which we developed. So very short introduction for the motivation since we lost a bit of time. For short, it's clear that the number of online collaborative learning courses and the enrollment counts of students is ever increasing. And since we want to provide formative feedback within these collaborative learning, we need a high amount of oversight within these courses. And therefore, a manual analysis of every message and every reaction and so on is not really possible. And learning analytics can for sure be a tool or a tool set for educators to provide that feedback more efficiently. But most studies we found implement dashboards and static visualizations for the learning analytics. And we found that to be a little inflexible for our approach. And therefore, and due to the fact that conversational agents have a long story in OCL, or especially in learning, in general in learning, we wanted to bring up a combination of both of these topics. So how we derived that? We started with a short literature review and derived a little bit of knowledge or grounding from our knowledge base. And further, we conducted group interviews with different educators about possible use cases for such a conversational agent system, which we then generalized into or derived requirements from them and then generalized them to design principles for such systems in general. And in order to evaluate our progress, we built an exemplary implementation for such a conversational agent, which implemented all the requirements and design principles we had worked out. So since it's in German, I just wrote some simple explanations of the translation onto the text. So we have two message types here. The first one is that we have from our first derived design principle, natural language-based analytical interface for teaching staff or educators. And the educators could just make simple queries like show me the length of messages in group 1 and 2 or for a student, etc. ABC, and compare them against each other with the specific time or in the last 2 weeks. And the conversational agent will answer with some short introductory texts and as well with the displayed analytical data. This is the second design principle to support the formative assessment for sure by the supply of activity data, especially since that was the most requested and the most useful data in order to bring up or to support formative assessment within learning analytics for us. So the third design principle for us was automated adaptive language notifications for the learners. And especially here, it was implemented in a way that the KPIs or the measures of the activity was interpreted within a text and as well with the same graphics that the educators can receive within regular automated feedback messages that went to the groups of students, so that the groups can compare their activity behavior against other groups or the average of the other groups. And that helps them, especially in the early semesters, to just find the right balance in communicating against over-communicating, under-communicating. And it was perceived as a helpful tool for them. So that's my short 5 minutes. And if you want to contact me, you can reach out for me via mail or via ResearchGate. And for sure, over every other channel, I will join the LinkedIn group later today. So that's for my presentation, and I'm open for the questions now.
Great, thank you. And feel free to clap or put little clappy symbols on your on everyone's view. And by the way, if you didn't have chance to write down Sebastian's email, it's also in our agenda listed in the agenda table. So feel free to do that as well. Great. Let's see if you have if anyone have any questions. And if you have questions, don't forget to unmute, or you can raise your hand if you like as well. So I have one.
Yeah, sure.
Sebastian. So I know it's in German, but how feasible would it be to implement the same tool to, like, say, English speakers? Is it just a nature of, language processing that needed to be done, or is it just other?
Yeah, actually, we're working on quite exactly that right now for our next course, because in the first implementation, we used the German-speaking course for the sake of simplicity, that we had available. And for the next round, we will make a bigger scenario with some students from Albania and Germany together in joint groups. And within this scenario, we will provide it in English. And therefore, I have some resources to just adjust the language processing on the first side from the messages towards the chatbot. So for the identification of the intent and so on, and for the language generation afterwards as well. So that's feasible for English as well, and we are doing the adjustments right now.
Great. And Ed made a comment that it's great to see the emphasis now on educator instructor portion, not just a learner. And it's great to have a dashboard, because we all need the visual kind of representation of it. So thank you. And if anyone doesn't have any other questions, let's.
So I see a hand up. I don't know exactly his name.
Yeah, I think I see a hand up too there. What was that?
Yeah, I have a question. I'm
Okay.
Jani. Question about the design principles and how you found the process searching for these design principles. How systematic literature review you conducted, and yeah, a little bit like opening up the process for finding these design principles. I would appreciate.
Yeah, first of all, I think it's a little bit too complicated for this short presentation for me. So in the paper, we mentioned that we have just implemented like a Hefner design cycle for the artifact. and within this design, we have implemented or derived the design principles. Can you maybe specify the question, because I think when I start talking now, we are largely over the time.
We got about we got 1 minute. 1 minute.
Yeah, I was just wondering if you conducted the systematic literature review to find out those design principles, or was it more like explorative?
No, it was exploring the knowledge base on the first side, and on the other side the use cases from the group interviews, and therefore we derived requirements and then generalized up to design principles with the knowledge base in mind. But if you have questions about that, you can always write me. And also it's mentioned in the paper a little bit more explicit.
Yeah, thank you. Definitely will look at that. Thanks.
Okay, that's time. That's the time. Thank you.
Perfect.
On point.
Yeah, I suggest actually authors, if you like, feel free to link your paper also to LinkedIn group as well, so that in addition to slides, everyone has access to your actual paper to read as well. It should be already available. So if you can find it, let me know. I'll show you how to get to the Hicss proceeding portion, so you can link to it. Okay, great. Well, thank you so much, and let's switch to the, well, it's still, we're talking about AI applications. Great. So Anne and Isabel, so this time Anne will be presenting, and Isabel, so they will be presenting on AI agents, humans, in untangling the integration of artificial intelligence in learning environments.
Hi, and thank you. Good afternoon to everyone. My name is Isabel Peterson, and I'm a professor from Ontario Tech University in Canada. And my collaborator is Professor Anne Hill-Dewin, University of Minnesota in the United States. We're both members of the Digital Life Institute, which hosts this research through several ongoing projects, which we are going to present in brief today. For this paper, we aim to analyze how both humans and AI technologies are framed as agents through corporate advertising in order to assess learner agency, how learner agency will be developed in complex learning environments as products are deployed. Over to you, Anne.
Thank you. As we investigate these AI agents, we observe that the boundaries between human and artificial decision-making are often blurred, because learning takes place, as you all know, across distributed multiple platforms at school and increasingly at home. You think about the home-based Alexa that helps students with homework. I know it certainly does with my grandsons. Therefore, we address a key research question. Can we effectively develop agency, trust, and interventions to support learning in these complex environments where these boundaries between human and artificial decision-making become blurred? And more specifically, we ask, how are both humans and the AI technologies framed as agents with agency? How are learners framed by this corporate advertising as part of this blurring?
Drawing on Anne Catherine Hales, we acknowledge that our, quote, cognitions enmesh with technical systems in distributed cognitive assemblages, and that learning environments will further that entanglement with learners. However, following Kate Crawford in her new book, we argue that AI developers obfuscate proposed relationships and do not address human learners who learn through embodied, relational, wider ecologies. Over.
So for this research, we used a public, open access cultural analytics database and repository to identify a subset of artifacts to then use as our data set for the analysis. I just encourage everybody on this Zoom to go to fabricofdigitallife.com. I mean, it's incredible. It currently holds more than 4,400 artifacts. Emphasis on, as you can see, video content there, but you can see the overall numbers here. And it hosts over 50 collections, most having been prepared by external curators. So you could prepare a set of artifacts based on what you're presenting today. And working collaboratively there then with the Fabric team members.
So for this methodology, we used Fabric of Digital Life to collect a data set of 17 video artifacts, advertisements for newly emerged or emerging AI technologies over the past 7 years. The data set provided us a means to analyze inventions promoted as having an educational function. These included advertising for consumer products or services on the market, as well as corporate artifacts proposed for future release, and those that are discontinued. We conducted a critical discourse analysis to interpret the ways in which corporate discourses construct the role of learning subjects in relationships with these emergent AI technologies. We identify key themes related to obfuscation of agency involving learning subjects through marketing related to AI technologies geared to emergent educational media. And we seek to disclose implicit power relations already implied in corporate discourses of pre-release technologies that not only introduce a product, but also introduce or habituate learners to practices involving AI agents. We found that idealized relationships are promoted in 3 themes in brief. The first found that AI agents are proffered for multiple audiences, and this interdiscursivity or blurring in the market mars the opportunity to properly assess how AI agents will empower human learners. The second found that some products are proposed as anthropomorphized AI agents framed as superior to human learners. Phrases in the advertising position humans as needing the technology in order to navigate a changing world. And third, the third found that artifacts depict robots as teachers in environments without human teachers to exemplify the trend toward automation of traditional teachers' roles, an idealized and sensationalized framing that we found problematic. Over to you, Anne.
So in summary, our study, we explored the relationship between human and non-human agents, analyzing how AI technologies are marketed for learning subjects through a critical analysis of this corporate advertising. Our exploratory research provides an initial methodology for identifying specific fabric artifacts and then analyzing them for a specific question, research question. And this led to, as Isabel just said, the identification of the 3 key themes. By obfuscating agency in marketing, these video artifacts promote understanding of the blurred role for us as teachers and learners adopting and adapting to AI technologies. Our purpose throughout this work is to expose the tangling inherent throughout industry marketing artifacts. We encourage researchers to use, again, these digital archives, such as this one, as a means to study and design AI learning environments to increase student and instructor agency. We thank you and look forward to the Q&A.
Great. Let's thank our presenters. All right, great talk. As always, the AI technology is something else in education. Please feel free to unmute and ask questions.
I have a question about, so you really kind of dive into agency and the agency of the learner in connection with the working with an AI agent. And you're sort of playing with like the idea of power when you talk about the corporate environment and the advertising element of that. And I guess I'm kind of wondering like what you've been able to unpack, particularly kind of engaging in CDA for your analysis of what's going on, sort of what the interplay between kind of power and agency it looks like.
Well, I'll start. Thank you so much for your question, and it's quite relevant. So we look to CDA because indeed it would enable us to sort of exemplify discourses that empower AI over, say, a learning subject in technologies that are often proposed for years before they meet an audience are tested amongst learners in a learning environment, or tested with actual students, or tested with instructors. So this was provided for us a means to begin to really unpack the ways that we're asked to adopt and adapt to technologies from sort of first contact, which are these advertising materials quite often. So I think the notion that AI is superior to human subjects is a broader discourse that is sort of quite, is wrapped around emergent technologies in many spheres and many sectors, not just educational forum. But indeed, we thought that was important for us to look at it in this kind of these 17 ads. Hope that answers your question.
I mean, it is extremely relevant. I mean, the agency of the learner, agency of the educator, and that power interplay, and then and how we are conditioned to these through that advertising to expectations of them when, and what is behind that marketing at the same time, something marketed here is also marketed for learning, and then how that changes agency.
Great. Jim, do we have a couple of minutes for Andy's question?
2.5 minutes left.
Perfect. Andy.
Oh, thank you first. It's very interesting topic. I have a question. Do you have focus on any group of AI application or just AI in general? Because AI is quite broad. Because just like for example, deep learning apply to analyze some data is also called AI. Or if we using test to switch to test in a classroom, that's also called AI. So do you focus in any particular type of AI technology, or you just talk about investigate, explore the AI as a role of the agency in general?
And do you want to answer?
No, I was going to say, go ahead, because it helps to just better identify the focus on learning.
We filtered through, it's in the paper how we filtered through the artifacts that we decided to use for the data set. We started with a much broader category of emergent AI applications and whittled down to a set that included robots, AI chatbots, and other technologies. And our criteria was that it had to be proposed for an educational environment. It had to be, it was meant to be commercialized. For example, it had to be either coming to the market or on the market or discontinued from the market. So we discounted in that case research projects at universities until they were discussed their commercialization. And and came up with that 17 that are part of Fabric of Digital Life. But if you filter, there are hundreds of technologies, AI technologies that Fabric is charting and tracking over different sectors.
Thank you. That's in there.
Great. As always, very interesting. Thank you so much. And from AI, let's switch to immersive technology. So we have two presentations on immersive virtual reality. And we'll start with Tim and his team presenting, because it's a group of authors. And the presentation is toward routinely using virtual reality in higher education.
Thank you very much, Olga. Everyone can hear me well?
Yes.
Okay, that sounds very good. Yeah, good evening from my side, everyone. Almost off to bed, but time for a short presentation and hopefully for some questions from your side. I today have a talk for you on using VR in higher education. Maybe some of you recognize this topic from last year's session. So we've been working on a project on this topic for 3 years. And this is the final paper that concludes this paper. And after studying the topic from both the theoretical point of view and from the practical point of view, we hope that we can give some hints on how to get more routine on the topic. Quick look at the research motivation and relevance. I guess all of you would agree that VR offers a higher level of immersion, presence, and interactivity, and therefore has some attractiveness for learning. We think it's particularly suited for experiential learning, and it will also give some additional opportunities on top of what we do in terms of learning technologies already, so to speak, to enhance what we can already achieve. There are many challenges, however. First of all, hardly anyone working in higher education has an infrastructure for VR. There's huge financial aspects in terms of the equipment just is very expensive, and educators typically lack the skills in building immersive environments. And therefore, the research gap we identified is to say current applications of VR in higher education in most cases so far have an experimental character, and there's hardly any guidance out there for those who would like to do something or who would like to improve what they've already done in these terms. The current literature is structured into 3 streams according to our assessment. There are many design-oriented studies where things have been tried out and then run in a course, but in many cases not analyzed in depth, so not really studied how did it change things, how did it probably improve learning. There's then a second stream of short-term VR experiments. In these, the typical case is someone tried out something in VR and compared it to a classical learning or to another learning technology. These are interesting studies, but limited in scope. And then there are some works going into the direction of long-term evaluation, real-world courses, and that is also what we've been doing. We've been designing 3 research cases in 3 different institutions, in 3, I would say, quite different settings with relatively small groups of participants to find out what works and what doesn't work. And to just give you a glimpse on what we've been looking at, we had one research case that tried to engage students in a group work using a kind of virtual whiteboard. Sounds simple, but was very well appreciated. It was a kind of addition to the pandemic online teaching, and the students felt more engaged by that and also appreciated this interactivity. So one anecdotal example would be in the Christmas session, or the session just before Christmas, students would use virtual objects before class to decorate a kind of Christmas tree. And that gave this feeling, okay, they like this experience. Second case was on student playing a kind of VR learning game that was adapted to course content. So trying to transfer those course content that made sense into a virtual environment. And the third case was not so interactive, but rather one that transferred video to the virtual space, offering students in an IT security master the possibility to experience the work in a security operations center. We came up with a number of recommendations based on what we've been doing here. We think that if you do VR in higher education, you need a clear teaching concept. If I tell this to you guys, all of you say, okay, if you do teaching, how can you do it with a teaching concept? But the reality is, since most VR applications so far are just experiments, they often lack a concept in the background. There should be thorough testing. Again, a no-brainer, but something that so far is quite neglected. And those who test the VR applications should not be the students. We think accessibility is needed. And that is both in terms of how can students comfortably use VR gear, but also in terms of how can you make it, for example, hygienically usable. So in pandemic times, you can't simply say, we put 50 people into a classroom, let them just share the devices. That would be against most rules currently in operation. We think thorough preparation is needed, particularly in a setting where most of the work is experimental. We think students should be provided with tutorials. So even though you can say VR is quite appealing, VR is quite easy to master, it's not as easy to all students. So they should be guided. We think short experiences make sense in small groups. So just saying I take my 100+ hour course and put it into a virtual world and throw hundreds of students at it and just see how it works, that is a very bad idea. The physical space is an interesting aspect. We found that you need at least 2 by 1.5 meters for a safe experience. Some people will be walking around and moving a lot if really immersed. And that can become dangerous, particularly in a home setting where you typically don't have that much free space. We think that VR should be also space for fun. So the motivational aspect is something that we would really highlight. And we also think that you need good follow-ups. So some people imagine if you use VR in educational settings, you can just put what you had before in an offline setting in a virtual world and everything will be fine. But the reality is you have still the classical teaching, then you have a VR aspect, and then you have more teaching. And the better the VR becomes integrated, the more it becomes an add-on that improves things, the more successful will you be. Final quick look at our contributions, limitations, and future research. So we've been working a lot on the theoretical background. That is mostly what I presented last year. We now have looked at the practical implications. These were the recommendations I just gave you a glimpse of. However, what we've been doing so far, of course, is limited, and it poses some of the limitations that we also criticize with regards to literature, particularly this experimental nature of it, and no big numbers that you could say we did something that would have significance in a quantitative sense. So most of the work that you will find, including ours, is qualitative. Therefore, for the future research, we would like to do the things that we've been doing already with a more long-term outlook, and therefore really contributing to what I titled this paper to say we would like to do it routinely. And with that, thank you for your attention.
Great, thank you, team.
Yeah, we got about 2 minutes for questions, Olga. 2 minutes.
All right, perfect. Let's see if you have any hands. There's one hand somewhere.
Mitch and Susheta, I think, had hands up.
Yes, hi Tim.
Just throw it in. Hi.
Yeah, it's Sucheta. So I'm a third-year student, PhD student in Syracuse University, and I've done a little bit of work in the immersive technology. So when we talk about the immersion in virtual world, there's something called as Proteus effect, which actually perpetuates a lot of stereotypes. So when we create an identity for ourselves, or in other words, the avatar, we there is a lot of stereotype, stereotypical behavior attached to that avatar and identity. So I was wondering, what have you thought of, in terms of giving the identities or the avatars of the student that might kind of address the question of, behaving in a certain way in a 3D environment, or, like talking in a certain way. So I was more interested into looking at the behavioral aspect of it. And secondly, Oculus as a VR tool or aid, I don't know what word would be appropriate for it, at times has a lot of side effects, like people have headache, and some have also complained of nausea and all. So do you have any sort of vision or improvisation that you would want to suggest, especially to students who already have a lot of fatigue with pandemic and long hours of Zoom calls going on? So what are your future thoughts on making this a little bit more easier so that they don't get swamped with n number of technologies, and and they don't get all these fatigue and exhaustion? Thank you.
Yeah, thank you very much for the questions. I think both is extremely relevant for the future outlook. The question about how people are easy with using VR definitely is not an easy one. Some people have suggested you should go for the expensive stuff, but use simple stuff and let it more at the student's discretion. But there works, I think among them also work by Olga out there, that suggests that the level of immersion and maybe also the feeling about the devices when you use like Google Cardboard might not be so comfortable. And then you might be better off with the more expensive stuff. However, the reality to my impression and also to my knowledge of the literature so far is don't have a solution that will fit all people right now. Some will get nauseous, some will get uncomfortable, and you can do not too much about that, but to limit the time and try to make people, say, psychologically comfortable with using VR. So we found that the way that students can approach using VR has a lot of effect on how comfortable they are with it. So can they try that out in a secure environment? Can they try that out without force, without maybe the feeling other students are looking at them while they are wearing the glasses and mocking them? And if they got accustomed to the technology, then there will be fewer cases of people having problems with using it. What I personally think is very important is that you don't make VR a kind of digital divide tool where you say those who have the natural condition of being more comfortable with it will have a greater learning success to those who can't use it. And I think that is posing a lot of questions for future research that need to be answered, both from a behavioristic point of view and from a technological point of view. Getting to the first question, we haven't been working so strongly from this behavioristic point of view. So advising how to design avatars to offer, say, a certain kind of behavior to stimulate that, I can't really answer. What I can say is that the impression is that there are several factors that increase or limit the immersion. Part of that is how realistic the environment feels, but definitely as important is how much people can identify with what they see and what they perceive and how they can behave in the virtual environment, how much they immerse in that. And our observation definitely is if people will get immersed, they will in a way start to behave ethical, at least if they would in real life also behave ethical. So just to make a stupid example, if you have a very simple computer game where you could say kill people, if it's not immersive, people will have less problem with killing people, like running them over with a car. Then if something is immersive, then people will start to behave ethical and think, no, it's wrong to do that. And that is an interesting experience. So the more the immersiveness, the more maybe ethical the behavior.
Great. Thank you so much. And Susheta and team, I know the question was great and it may take longer than we would like. But I really suggest to continue all the conversation on LinkedIn group. And I was hoping when we started the LinkedIn group, I was hoping to start actually discussion with all those questions so we can support each other. So that would be a great question to continue, obviously, absolutely on our LinkedIn group. Great. Let's move to our second presenter, Yanni, with immersive virtual reality education application for development, iteration along design science research methodology.
Okay, thank you. And thank you, Olga, for pronouncing and introducing the topic. So my name is Jani, co-authors here, my PhD student Antti Lähtevän-Oja and Professor Tuure Tuunanen. So a few words about the design science research principles. I noticed that a couple of other previous presentations have been mentioning design principles and design artifacts, but just to make sure that everybody are on the same page. So design science research is all about the problems and solutions, problems based on the real world relevant problems or literature revealed problems, and theory-informed solutions. Design science research is also about seeking improvements instead of absolute truth. So as we know that it might be very difficult in complicated systems and environments to find the absolute truth. So we are trying to seek improvements to the current conditions. And the next, well, this is kind of like a framing my presentation and also the application versions that I'm introducing in the next couple of slides. So first version and the problem and the research question being how to provide scalable online courses with improved interactivity. So basically, well, MOOCs, massive open online courses, they are scalable, but how to include and increase the interactivity. So we introduced VR and 360 environments with the VR cardboards to these MOOCs. So basically we are sending out 300 VR cardboards to the students who were also participating in these MOOC courses. And the findings from this first application versions, well, first of all, we were able to prove that MOOCs and VR cardboards and interactivity in that sense can be scalable. We also gained some evidence that the interactivity improves learning, and also found out that there's some evidence that VR does not work on lower learning levels. So basically we were observing, as in many other of these version evaluations, we have been observing learning according to Bloom's taxonomy. So the lower levels means they're understanding and remembering learning levels. In this version and evaluation, we also found that there's a small tech savvy group favoring 360 environments and VR technologies. Second iteration and development version, and the problem here occurred basically from the previous version, and here we tried to improve the learning results in VR. And for this, we created a solution artifact, basically trying to achieve the higher level of learning through personalization of tasks with immersive VR. So here we used head-mounted displays instead of VR cardboards, and also we're able to, through the personalization, we were able to create more higher application level learning environment. And findings from this evaluation round. So here we found some evidence that VR works on application learning level. We also experiment with different learning contexts, and the learning context, again, it didn't seem to have any significant effect on those lower learning levels. But here again, the lower learning levels being the understanding and remembering levels. VR was found to enhance also the positive image on teacher, and we also found that learning outcomes mediates learning experiences. So this means that if you are not achieving positive and high learning results, you cannot achieve positive learning experiences either. And definitely the main outcome out from this research or this version evaluation was that personalization is one way to generate higher levels of learning. So the third development version, and here we try to answer the question how to create cost-efficient 3D environments and how to use them in courses. So here we developed a design artifact which was based on 360 photos and video environments, and also combining advanced pedagogical models. And especially we were observing the skills development among the students. So findings here, 360 technologies appear to be fast, cheap, and personalized way to create VR content. That was proved under this evaluation round. We also found some evidence that VR and online courses are complementary, and their parallel use is advised. So we found that VR works well in experimental learning, discursive learning, and supportive learning, while learning by doing is supported by both environments. And then online course format was better in critical thinking, conceptual change, and self-regulated learning. Then the fourth version round, and here we've been trying to answer the question how to simplify 3D content production and relate course models. So basically this is a development version, application development version under under development. It's on our desk, design desk. But in the solution, we try to consider all the previous suggested solutions, and in addition to those, we try to create a simple and scalable model for teachers to generate VR content on online terminal. So the online terminal would be the answer to create like a to create simply and scalable content by the teachers. Simple and scalable model for students to carry out VR assignments is also planned in this application development version. Scalability, we try to ensure it by choosing the technology, which is the standalone Oculus Quest 2. So in the previous iterations or development versions, we've been using like not standalone devices, and that's why probably that's the reason also that the scalability has been suffering. Here we are also introducing a new adapted pedagogical model, and basically we are also combining the online and VR elements, and probably that is also like my answer would be for the previous such a question about the what are the like the these effects of the VR and how those can be overcome. According to our knowledge so far, and suggestions are that we should combine different learning environments and taking like the best parts of different environments and putting them together. Okay, thank you. Mahalo.
We got 2 minutes for questions, Olga. 2 minutes for questions.
Perfect. Well, thank you so much. And let's see if you have any hands up. And Gustav,
go ahead.
Yeah, thanks a lot for your presentation. I mean, when you talk about learning outcomes and learning results and Bloom model with learning content based on virtual reality and 360-degree videos, it always depends also on the kind of content you are providing. I mean, we are also participating in an EU project in a very similar area, but we are coming from a business university, and it's not so easy to come up with good learning scenarios there. Therefore, I wonder what kind of learning content you have used in your experiments and for what kind of subjects these have been.
Oh, thank you for the question. Obviously, it's all there in the paper. As there's like a different development rounds and evaluations, there's like several different learning contexts and environments as well. There's like from sewing, there's from machinery, there's from biology, there's from mathematics, very different learning contexts. But we've been trying to generalize the results, and I would say, because you are referring the Bloom's taxonomy, and I guess like one of the key findings that we've been finding out is that the personalization is a way and key to move up on those learning levels higher up.
Thank you. I mean,
all right. Okay, Tom. Thank you. Thank you so much again, Yanni. And we let's continue a conversation. I really encourage everyone to start building our cohort. First with the LinkedIn, and hopefully we'll meet in Hawaii next year to have a stronger community of educators who are well versed in learning and teaching technology. With that said, so we covered AI applications, we covered in immersive technology. So now we're switching to innovative approaches. This is a term I came up with because we there's so many things, and it kind of go well with innovation. So because there's different theoretical and applicative methodology offered, and we have 7 papers submitted in our panel, but we'll hear a presentation today of 6 papers, and the first one will be paper by Zhao, Funk, and Sean, Posting versus Replying, the Effects of Instructor Participation in MOOC Discussion Forums.
Oh, hi, this is Funk here. I'm going to present, but I cannot share, so I'm asking my colleague, Dan, to share the screen. Thank you. Oh, okay, here it is. Okay. So our topic is posting versus replying, the effects of instructor participation in MOOC discussion forums. So this is an empirical study. The co-authors are Dr. Zhao Du of Beijing Sport University and myself at Wilfrid Laurier University and Dr. Shan Wang at University of Saskatchewan in Canada. Next page, please. Okay, so the context is the needs of understanding instructor participation strategy in MOOC platform. So the previous literature clearly indicate that online discussion is a very important and effective tool for student learning, and online learning suffers from insufficient student participation. So I guess everybody is teaching online and everybody probably observes that similar situation. It's really hard to engage students in online situation. And in the literature, there's various methods that has been investigated on how to improve student participation. For example, there are involvement of student facilitators, use of computer-supported cooperative learning, pedagogical and social methods. And among all of these different tools, it is found that instructor participation is one of the most effective. And research on instructor participation has traditionally been conducted in the context of small online classes. So when I say small online classes, I refer no more than 40 students. And on average, if you look at the literature, about 20 students in online classes. And MOOC, which is the current trend in online education, has an enormous large class size. So if you look at our empirical data later, I will report the average class size is about 8,000 students. So this enormous large class size poses a challenging context for instructor participation. Next page, please. Yeah, so our research question is, how does instructor participation using posting versus replying in online discussion forums affect the student participation in the MOOC platform? When we say posting, posting represents instructors' proactive participation in online discussion forums and their direction in leading students' discussions. So this posting or these posts starts new threads of discussion that are open to all students to reply. So for example, you post a question and you ask all the student comments, to reply or, to discuss, right? Or instructors can participate while replying. Replying represents instructors' reactive participation in online forums and their efforts in dealing with individual students' questions and comments. Because these instructor replies are embedded under students' post, they are less visible to students, but their issue addressed are usually pragmatic to students' difficulties or challenges they feel. The next page, please. The next page, please. Hi, my colleague, can you please change the next page? Okay, so
it might be frozen too.
Yeah, I'm sorry about that. There must be.
There you go.
Okay, so here we are. the conceptual framework, right? So you see my hypothesis 1, hypothesis 2 are main effects, and the hypothesis 3 are moderators of class size, because class size is so important in the MOOC platform, and MOOC are very large, and traditional research are in small class size. We saw that the first step is to test the moderating effect of class size. We actually find interesting results. So hypothesis 1 is that posting increased student participation, and hypothesis 2 is about replying increased student participation. And then the moderation of class size is hypothesis 3. Next page, please. Okay, I think there may be a delay there in the online response. Okay, so if there's any delay, I'll just go on, with my talk, and then maybe you can catch up with the slides later on. Okay, so the data, we scraped data from a leading MOOC platform in China. This final, we did some data cleaning process, which I will not discuss in detail in this short presentation. The final data sets include over 16,000 classes of more than 4,000 MOOC courses, and it contains about 200,000 instructor posts, or actually about 2 million instructor replies, and a total of more than 62 million student posts and replies. And we did class level data and analysis. Our dependent variable is student participation measured by the average number of online discussion forum activities per student per week in a class. And instructor post and instructor replies are our independent variables, which are respectively measured by the average number of posts or replies per week published by an instructor in an online discussion forum of a class. And the moderator is class size, right? And there we control a bunch of control variables, especially the class level control variables. Next, yeah. So this is our descriptive statistics. If you can see that there are very interesting information embedded here. The average student participation in online class, 0.05 per week, right? So it's very low. People don't usually participate. And if you look at how instructors participate, right? So the average of the posts is about just below 1 per week. And the average per reply is about 8.5 per week. So that means instructors actually replies much more than they post, right? So which is, totally understandable. It's much easier to respond to other people's, question instead of thinking what you want a student to discuss, to be proactive, right? And the class size, if you look at it, average is 8,200 students. It's a very large class size. The next page, please. Yeah. So we plotted the relationship between class size and student participation, and we found an inverted U-shaped relationship. So as the class size increased, students actually participate more until about our average, about a class size of 8,000 students. Then, because the class becomes so large, students' participation actually decrease. So the implication here we found is that maybe, instead of, not setting a limit of class size, the MOOC platform should actually set a class size limits based on their practical findings there. Next page, please. Yeah, so this is a quick summary of our results, right? So if you look at model 1 and model 2, we analyzed the relationship of total instructor participation on student participation, and model 3 and 4 are more pertaining to our specific hypothesis testing. right? If you look at all the stars I marked there, hypothesis 1 and hypothesis 2 are both supported. So that means instructor posting and replying activities both enhance students' participation. However, if you look at model 4, right? So that's our testing for hypothesis 3. You will see that the interaction term between class size and instructor posting is not significant, but the interaction term between class size and the instructor replying is significant negative. So that means as class size increase, that the effects, the positive effect on instructor replying on student participation decrease. So the instructor replying become less effective. But then instructor posting remain a similar effective, no matter how large the class size become, right? So the implication I write on the left side of the slide, as class size increase, posting become more important than replying. However, if you remember, if you recall what we discussed in the descriptive statistics slide, instructors actually participate much, much more in replying than posting. So the average weekly participation through replying is about 9, and average weekly participation through posting is less than 1, right? So there's a gap there. We should inform the online platform and online instructors. Right? So this is basically what we did our research. So the next page, our final page here, right? So thank you very much for the opportunity for us to share of our work. And I also want to do a small announcement or advertisement. The co-authors and I will actually hosting a track on information technology in education, which is totally relevant to our stream as well, in a conference called the 21st Wuhan International Conference on e-business, which is a conference will be held in May this year. And at least the website of this conference here, and the submission deadline is January the 20th. And we welcome submissions and hope to see you all there as well to continue our discussion. Thank you very much.
Thank you. Thank you so much.
Olga, we're out of time on that one. We're out of time on that one.
Right, thank you. And thank you so much, Wang. And I suggest to post this information about your conference track on LinkedIn so we can all kind of attend and see if we can submit. So that would be great. And maybe link on chat room so we can copy it as well. If you can do it, great. Thank you so much. And since we run out of time, feel free to post your questions directly in the chat room so we can later on direct them to Fang Shan and Zhao, or if not, just keep conversation on LinkedIn. Great. So let's move to the second paper by Gustav and Alexander towards better support for machine-assisted human grading of short text answers.
Hello to everyone. Sorry, I've got to unmute myself. So I will take over for our presentation. And
can you make it yourself a little bit louder? Sorry.
Yeah, I can speak a little bit louder so that you can understand it more clearly. Okay, then let's start with the presentation. I will talk about the better support for machine-assisted human grading of short text answers. So what was our goal? Our goal was to do a short text answer grading tool with little and with the background of text with little and heterogeneous texts in the background. It is to assist a human grader rather than providing an oracle to them. It is another goal to support incremental grading rather than finding something out of the box and do the grading for them. and to detect anomalies via text similarities. And for that, we propose two new ways of approaches, which then come later to it. What are the requirements for this tool? We wanted to use it for real-world exams. So there exist bad spellings, it must be robust to achieve good results and so on. So it must have a little setup costs. So there is no golden essay and no corpus modeling required. We wanted to form a tool which is language independent. So we conducted it for German and for English. And it should be subject independent. So it can be used for any subject. So what was our approach? We did it in 3 steps. So first we did a classical text processing pipeline based on NLTK and or textual distance measures. Then we developed 2 novel measures, which is the first one, natural variability, and the second one, answer completeness. And the third step was to build a Python-based infrastructure for the assessment handling, which can also be found under this link provided in this presentation. After that, we did an evaluation of it to compare the results from manually graded exams with automated graded ones based on classical short text answers. From the literature. So we used a published data set of Mola et al. And also used our own data sets from our own university. So here we would like to present those 2 novel distance measures for submission comparison. So the first one is natural variability, which in other words means expressing knowledge individually. And this is mostly suited for those questions in exams like express in your own words, or do it and write it down individually and with your own words. So this measurement is based on 3 by and unigrams. So they are weighted for the severity, and then the variability out of it is then basically the inverse of it. So it is basically the absence of or the presence of identically occurring 3 by and unigrams. The second novel distance measure is the answer completeness. Here we wanted to propose a measure which computes the difference or the similarity between one individual submission against all the other submissions. And the reason for that is that you don't use any corpus at first, because you use the all submissions at first. And on the other hand, you don't need any golden essay, so don't need any right answer to a certain question, because you always compare the whole set of submissions against an individual one. So what were our results? We compared the Yarrow-Winkler distance measure against our natural variability. For that, we used the cluster analysis to identify submissions with similar properties for incremental grading. So here we have one question with 29 submissions. On the left-hand side, you see the Yarrow-Winkler distance measure, which is a characterized text comparison and is well suited for dealing with misspelled words, which is basically the most frequent obstacle for short text answers. And on the right-hand side, you see the natural variability cluster analysis, where you can immediately see that the top scoring exams or submissions are clustered on the right-hand side. And in the left graphic, you can see it is spread over all clusters. So the result is that for good submissions based on manual gradings, you have a very similar natural variability. This means that it is very suitable for incremental grading, and this is also for assuring the quality of your grades. So you can easily take one exam out and then step to the next one, and this should be of several an equal grade. The next one is about the answer completeness. For that, we want to correlate answer completeness with the reached grading percentages. So to say a grade predictor. Here you can see one exam with 8 questions. And as you can see, there is a positive correlation between the percentages granted or reached in a submission and the similarity level. So that means that the results it can be interpreted that it is a good predictor for questions like expressed in your own words, where you don't have any golden essays in the tool, but when you would have one, it would fail because you always compare it with this golden essay. But for our approach, it easily can be seen that without any golden essay and without any given right answer, it easily detects a higher percentage of the grades to the higher similarity. So I wanted to summarize the actual presentation. So what requirements did we achieve? We used it for real-world exams. We did have a little setup costs. It is language independent with just one tiny exception, which is that all answers must be in the same language. And it is also subject independent. Which lessons did we learn and what is the future work of it? We finally detect anomalies via text similarities, but we need a deep understanding of the question characteristics because no algorithm leads to the best results for all question types. So probably the pre-processing can help, but you have to understand the question characteristics to usefully and rightfully select the correct algorithm. So far, only analysis was done of previously created exams, and the performance is now suited for interactive usage. So we can deploy it in the larger scale deployment in the setup with lecturers of arbitrary fields, and this would lead to a better integration with learning platform and to gain more realistic and larger scale results and prediction out of it. Okay, thank you very much.
Thank you, Alexander. Thank you, Alexander and Gustav.
We've got about 1.5 minutes for questions on this one. Did you hear that, Olga?
I don't see any hands.
Yeah. 1 minute. Actually. Okay.
Okay. Then thank you very much.
All right. Well, thank you. And again, do not forget to post your questions if you have on the chat room or LinkedIn. And if you have questions specific, all the papers will be available as well. So make sure you reach out to the authors. All right. Well, thank you so much. And let's move to third paper by Daniele, David, Christoph, and Falk. InnoPulse, a tool to support collaborative reflection in creativity-driven engineering projects.
Hello, everyone. Good morning, good afternoon, good evening, what part of the world you are now. From my side, good evening. I'm located in Brazil at the moment, visiting my family. So the paper that I'm going to present today is called InnoPulse, a tool to support collaborative reflection in creativity-driven engineering projects. The paper was written by myself, David Hahn, Christoph Mattis, and Falco Bernico, and I will be the presenter of today. Then let's get started. So to equip students with the practical capability to innovate, many universities nowadays, they are promoting a collaboration with industry partners, where students use design thinking to solve complex business challenges that are proposed by these industry partners. As we know, when we are talking about creative teamwork, the ability to reflect on our experience on the steps of the project on the outcomes is really crucial, especially when we are talking about ambiguous situations. However, the understanding of what is the role of digital technology when supporting collaborative reflection is still in its infancy. There are already existing solutions in this direction. For example, the work of Schumann, which was even published here at Hicks, and the authors propose a software tool that is able to support teams to perform reflection sessions during an entire design thinking project. However, the need for the user interaction with the computer is a limiting factor. It provides a barrier in that case, as reported by the authors. And to lower the technology barrier, many researchers, they suggested to borrow concepts from educational data mining and also digital microsurveys. And with that in mind, we developed a solution that uses microservices and also educational data mining to develop a digital solution that supports student teams to perform creative, collaborative reflection in creativity-driven engineering projects. To develop and evaluate our solution, we used design science research, which is a well-established approach here in the information systems community. And it's mainly used to develop and evaluate a digital artifact. So how did we apply the design science research? Basically, we followed 3 steps. The first step was the initial design, which had mainly 2 goals. The first one was to capture the practical relevance of the identified research gap. To do that, we interviewed 10 professionals who have experience in supporting teams to perform reflection sessions in design thinking projects. As a result, we learned that although teams are very much interested in doing these reflection sessions, there is the lack of a tool that helps them to systematically perform these reflection sessions and also to help them to record some relevant experiences. The goal of number 2 was to identify the design requirements and features for our solution. And to do that, we interviewed 12 master students from an university, and these master students, they were working in 4 different projects, so 3 students in each project, and they were working in an industry project while applying design thinking to solve an industry challenge. And as a result of that step, we identify design requirements and design features of our solution. The second step of the design science research approach that we followed was the development of the solution. And here I would like to present to you the solution we developed, which is called InnoPulse. So InnoPulse is a system that is composed of a mobile app and an online dashboard that you can see on your browser. The intention of InnoPulse is to send questions to the team. And these questions, they can be answered in an optional way. So the students, they are not forced, it's not mandatory for them to answer. And as you can see here on the screen, the question comes in the notification center. However, the user does not get a notification. We identify that it's very important to not disrupt the flow of the team while they are working. So in case they have the phone with them and in case they are looking at the phone, they might answer the question, but it's not mandatory and it's not going to disrupt the flow of the team. And here also on the left-hand side, you can see an image of the dashboard. And the team can see how the team members answered the questions over a period of time, which enabled them to understand how it varies over time, the experiences of the team. The final step was the demonstration and evaluation. Basically, we asked the 4 teams to use InnoPulse for a period of 5 working days. And at the end of each day, we asked them to perform a reflection session when we could observe how they were using the platform, using the solution, and also we interviewed them after the 5 days. We found that InnoPulse helped them to understand experiences in specific point of times. It was easier for them to remember these experiences and to reflect. It also improved their communication within the team. One challenge that we found was some students became uncomfortable in comparing their answers with each other because they gave answers in different time. And as conclusion, we found that our solution requires less user interaction when compared to the previous work. And it also enables teams to observe the development and comprehend how the team members perceive the experiences. It also allows the teaching team of the universities to analyze the learning experiences of the students and maybe identify some patterns. One clear limitation is the testing time, because we ask the students to perform reflection sessions at the end of each day, which limited their freedom to decide when it was the correct time to perform this reflection session. We would like to say thank you to our partners, the Sugar Network and the HPI Stanford Design Thinking Research Program. These are our references, and this is us. Thank you very much for your attention.
Thank you so much, Daniele, and the rest of your team. Please, if you have any questions.
Do you have any experiences identifying patterns in students' learning experiences? This would be a future direction of our work.
I have a quick question. So through using this tool, so my sense is that there are these sort of like micro surveys that are providing these data points for future reflection and then individual and then group reflection. Were you able to kind of discern what kind of benefits were coming out of using this tool in terms of how collaboration was happening with the team?
Yes. One of our findings was that it made it easier for the students to understand what experiences they will have together as a team. Because designing thinking projects, they are so intense, the emotional curve is so, it varies very much. And by using this tool, the students, they are able to identify how it changed over the day. And then it's easier for them to remember, okay, in the morning, I felt a little bit down in that particular step of the project. And now I remember why. In this other step of the project, I felt happier, and this was because. And before the tool, they tend to forget what exactly happened during the day because the day is so intense that they don't remember how their emotions, how the experiences change over time, which was a loss of opportunity to reflect on experiences.
Olga, you have 1 minute left. 1 minute.
Did I answer your question, Christian?
Do you mind if I just follow up on that? So with individuals within the team, the collaborative team, being able to sort of reflect on, at this time of the day, I was feeling, unhappy or whatever. Were you noticing then shifts in the collaborative environment in positive ways because they were able to kind of go through this reflection process? Yeah, that's basically the question, I guess.
Yes, so they were able to be more reflective, basically, because when you are working in design thinking projects, as I mentioned, reflection is very important because it's a very ambiguous scenario that you're working in. It's a very ambiguous setting. And when you don't reflect on what you are doing, you tend to be a little bit lost because ambiguous situations normally cause this feeling on people. And we have heard many times students say, okay, I'm very lost now, I don't know where to go next. And these reflection sessions enable them to see, okay, I was feeling lost, but then the process helped me to find my way. And now I see how the process helped.
Thank you.
Thank you, Christian, for your question, and thanks, Daniele, again. so much for your presentation. All right, let's switch to a slightly different topic in the world of gamified educational systems. So will be presented by Wilk, Camila, and Seiji, and the title is The Relationship Between Students' Flow Experience and Their Data Logs in Gamified Educational System.
I hope you can hear me properly. Thanks, Olga, for your introduction. So I will skip the title and this part. In this short presentation, I will try to present very quickly the introduction, the study design, with focus on the results, and the final of the presentation, just present some discussion about the study. So to begin, I think that all of us here know about the flow experience. That is a immersion kind of experience. I normally use a very informal description to define flow experience. That is the moment that you are, for instance, playing some game and you are very, very concentrated in the game, and normally you forgot the world around you, and you just keep your concentration in the game. This is the flow experience. And the flow experience is highly discussed in the field of learning, basically because there are a lot of studies showing that the flow experience is highly related with the learner experience. I mean that normally, if a student can achieve a high level of flow experience during learning, during a kind of learning activity, probably the learn experience will be high. So the flow experience is normally high related with the flow, with the learn experience. However, a big problem that we have is that normally it's very difficult to measure the flow experience, especially because usually the flow experience measurement is made by different kinds of questionnaires, scales, or interviews. And these generate two big problems. The first one, of course, is that when you need to use some kind of scale or interview to analyze some kind of experience, you need to remove the participant from the activity that they are doing. And of course, if the participants are feeling a flow experience, for instance, they will be removed from the flow experience. And at the same time, of course, it's very difficult to apply this kind of measurement with a big number, with a big number of participants at the same time. And of course, it's very difficult to analyze this kind of data. So in the last years, we are proposing a different approach to identify the flow experience of students during some kind of learning activity. And this approach is based on the students' behavioral data. Behavior data, in this case, I mean general data logs provide for the students during some kind of system usage, because normally, of course, when you use general kinds of educational systems, for instance, educational games, Moodle, or other kinds of systems, we are generating a lot of kinds of data logs, for instance, number of mouse clicks, number of completed tasks, how long time the students use during the activity, and etc. So our proposal is basically to use the students' data logs generated during the system usage to predict the students' flow experience without need to use questionnaires, interviews, or other kinds of measurement instruments. So for this specific study, basically, we used a gamified educational system called EgoEdu, that is a tailored gamified educational system that have a lot of educational games, game elements, and etc. To measure the flow experience in the first stage, we used the flow state scale. That is our very famous scale to use it to measure the flow experience. So basically, the most important part, I think, that is the method to understand how we conducted the study. So basically, we conducted a experiment where the students first used the gamified educational system for more than 10 minutes. During the time that the students were using the system, we are collecting the data logs, a lot of data logs in the system. And immediately after the students finish the participation in the system, finished to use the system, we collected the flow experience using the flow state scale. So you can perceive that after the system usage, we had the two main important information to conduct this study. That is, first, the students' data logs, and second, the students' flow experience. So we have the two informations that we need to conduct our study, the data logs and the students' flow experience. In this study, we had 25 students participate, and after we collected these two informations, basically, we analyzed the relationship between the students' data logs during the system usage and with the flow experience during the system usage. And for that, we used partial least square structural equation modeling. That is a very modern kind of data analysis technique. So we had a lot of results, of course, because the time of the presentation, I can't explore a lot all of these results, but it's interesting to perceive that you identify some kinds of negative relationships. For instance, we identified that points, points in terms of gamification, number of completed tasks, active time in the system, and number of completed missions negatively affected the action awareness merging. That is one of the 9 flow experience dimensions. I think that is important to highlight here, that we analyzed the flow experience itself, and we also analyzed the relationship between the data logs and the individual flow experience dimensions. And we had also perceived a lot of other positive relationships. Just one here to highlight, we perceived that the number of completed tasks and the average response time in the system have positive effect in terms of students' concentration. This means, for instance, that using the number of completed tasks of our students in a system usage, or using the average response time of a student in the system, we can, for instance, try to predict the concentration experiment that is one of the dimensions of flow experience using these two different data logs. And in the paper, of course, we have a deep analysis of these results. So to finish the presentation, just present here some discussions or some reflections. In the first moment, it's important to just clarify that in this study, we modeled the flow experience. So we identified a relationship between the students' data logs and the flow experience during system usage. But of course, this is only an initial step. In fact, in the last years, we are conducting a lot of different studies, but every time with the same idea, that is get students' data logs, students' flow experience, and try to analyze the relationship between the data logs and the flow experience. So far, we have different studies basically modeling and predicting the flow experience of students based on the data logs during assistant usage. But we need to advance our finds, and one important thing that you are planning for the future is to replicate the study, replicate the experiment with bigger sample, because, for instance, in this case, we have only 25 students, and of course, is an interesting starting. But with only 25 students, it's not possible to generalize our results. So it's important, and we are planning in the future to replicate this study with large samples and try, of course, to improve our results and try to have a more reliability in terms, for instance, of our values for in terms of prediction. So we are also planning to analyze the moderating effects, because here we are analyzing every time the direct relationship between students' data logs and students' flow experience. But maybe this kind of relationship depends of different moderating factors, for instance, gender, age, culture, and other kinds of aspects. And also in the future, we aim to use different kinds of data analysis techniques, for instance, machine learning based analysis, because normally to use this kind of technique, of course, we need large sample size. So, of course, we want to do even more, and one of the main aims of this presentation is to receive your feedback in terms of what do you think that we can do in the future to provide more reliability or more reliable results in terms of how can we use students' data logs or students' behavior data to predict the flow experience or other experience in educational systems. So here are some reference, and thank you so much for your attention. Time is running. I hope we had time to answer some questions and receive some
time is out. Time is over. Time is done.
Okay, but well, everyone, let's thank our presenter, Will, and please post your recommendation suggestions here in the chat room, or also use the LinkedIn. And also you have again, reminder in our agenda, there's a link, there's email address of the main author or the main contact person. So feel free to contact directly. All right, well, thank you so much again. And let's move to our so we have 2 presentations left. Are you still full of energy, everyone? Can you handle 2 more presentations? All right, so we have next Alina, Katarina, and Stefan presenting on technology enhanced learning environments and adaptive learning systems development of functionality taxonomies.
Yeah, good evening, everybody. My name is Alina Boxecker, and I will present the paper, as said before, Technology Enhanced Learning Environments and Adaptive Learning System, the development of functionality taxonomies. First of all, I would like to give you an idea of what we understand as a technology enhanced learning environment, as the technology enhanced learning environment builds the basis of meaningful design and the means of addressing the accelerated digital transformation. Technology-enhanced learning environments require but do not rely solely on the integration and use of technology in learning, in courses or classes, but it can help scientists in developing meaningful designs and practitioners in design as well as implementing those technology-enhanced learning environments. We found that a structured overview of technology-enhanced learning environment functionality is often left to further research. Therefore, we defined two research questions. The first one is, how can functionalities in technology-enhanced learning environments be divided into meaningful dimensions? And the second one, which of these functionality dimensions in technology-enhanced learning environments enable adaptive learning? To fully answer, or if you are interested in the full answer of the second research question, you may look in our paper, because in this talk, I will only shortly come to the answer of this question. We used a taxonomy development process by Nickerson et al. And we came up with a first taxonomy of functionalities in technology-enhanced learning environments. As you can see on the left side, we identified 11 functionalities, and I'd like to shortly present 3 dimensions of adaptability to use, so you get an idea of the function of the dimensions of the taxonomy. Basic automation includes systems, for example, that provide basic infrastructure and features such as content management and calendar. Predictive would refer to opportunities for monitoring, comparing students' learning process, and allows for the identification of potential difficulties of the learners. And automation goes beyond this adaptivity and refers to fully integrated systems enabling enhanced efficiencies, self-protection for security capabilities, etc. In addition to this, we followed the recommendation of Sopinski et al. To rigorously evaluate this proposed taxonomy. The authors state that an ex-ante evaluation is ensured by the objective ending conditions defined within the taxonomy development process. The authors further highlight that it is necessary to have a second evaluation, an ex-post evaluation. To do so, we decided to use a sorting approach. Therefore, 4 researchers were asked to sort the various dimensions to our identified functionalities. And the results were that between 93 and 76% of the 41 dimensions could be sorted to the right functionalities. In addition to this taxonomy that I presented shortly here, we have developed a second taxonomy, but I will leave this for you to look up in the paper later on. So with these 2 results, with the 2 taxonomies, we ended up in identifying 4 research opportunities. The first one is that researchers and practitioners should develop process models, for example, for the dimension that I presented within the taxonomy 2 slides earlier, that support the effective integration of an adaptive learning system in this technology-enhanced learning environment. Secondly, researchers and practitioners should analyze and discuss country-specific circumstances concerning the data underlying adaptive learning systems. as well as resulting effects on usage and implementation. Researchers could further test and evaluate new technological developments in adaptive learning system, exchange their studies and best practices with other scientists and teachers in order to enhance research and results in this case. And lastly, we have found that a discussion and further development of the functionalities and dimension would be helpful to enhance the knowledge about not only adaptive learning systems functionalities, but of course also about technology enhanced learning environments in general. Yeah, thank you very much for your attention, and I'll be glad to answer your questions.
Thank you so much, Alina.
That's 4 minutes for questions.
Okay. Do we have any hands up questions? I don't see any.
I don't see any. I don't see any.
All right.
Double checking.
As always, please feel free to post your questions. And I know there's so much information in so many presentations, and it's always great to look at the paper and then contact directly authors. Thank you so much, Alina. And let's move to actually 2 presentations we have left. So when I said 3, when I said 2 earlier, so actually we have 3 in total. So 2 more presentations left. So hopefully you got enough energy. If not, get some coffee so you can continue listening. So our next presentation is sense making of digitizing higher education, a need-based innovation approach for data intelligence, presented by Sebastian.
Yeah, hello everyone, and thanks for the introduction. My name is Sebastian Brank, and I'm a postdoctoral researcher at the Institute of Technology and Innovation Management at RWTH Aachen University in Germany. I will present in the next 5 minutes our study about identifying student needs to digitize higher education. As a motivation for our research, we see that traditional universities faced already before the COVID pandemic challenges and threats of disruption, because online education at universities is getting more and more popular and accepted. To cope with the digital change towards online education, traditional universities with the past focus on face-to-face or classroom learning are trying to shift their higher education offering from analog towards blended learning approaches. However, there is a high degree of uncertainty about the innovation, development, and implementation of e-learning technologies, and especially towards concepts of blended learning. To reduce this uncertainty, the innovation management field recommend to see the student as a customer for university education and identify first their learning needs to innovate. The current literature lacks methodologies on how universities can identify student needs for the innovation and implementation of e-learning technologies, and especially also on blended learning. For that reason, our study applies the so-called job to be done theory, according to Christensen, and the outcome innovation method, according to Ulvik. Here, a job is the fundamental problem a customer, like a student, needs to be resolved in a given situation. In the higher education context, universities must understand the job students are trying to get done, as well as the desired outcomes. They must identify the student needs and problems that help to create the basis for the innovation activities and lay the foundation for successful digitization. The outcome-driven innovation method is based on the job to be done theory. We use this innovation mixed method approach to identify student needs in academic education and to translate the needs into knowledge to innovate and develop technology solution for successful implementation. And this we did in the use case of the RWTH University. We did this in a mixed method approach, this ODI, and this was in a first qualitative study with 45 interviews. Here we identified the student needs from the learning process, also around e-learning. And from this, we could identify special 36 outcome learning statements, which we translated in measurable criteria. We then evaluated in a quantitative study, which was followed up. In this survey study, we asked in a sample of over 3,000 students of our universities, according to their importance and dissatisfaction of each need. So we can say if a need is important for them, and is it on the other side satisfied. And so based on this, we could then identify overserved and underserved needs, which are important or unsatisfied. And this need information could then be used to translate into technical solution. From our results, we could then derive a so-called opportunity map. This map clusters and shows the student needs according their importance and satisfactions. And here we can see especially 14 opportunities, so-called unfulfilled needs of students, which have high importance and low satisfaction. This is called an innovation opportunity. So here we have a student need, which is high in their importance, but not satisfied at the moment with the technology undergone. We then can, according to this ODI method, rank these outcome statements. So the outcome statements are really the needs the students have, from high importance and low satisfaction. And overall, these needs were used for the sense making on a higher management level for the digitization strategy and blended learning strategy. And we could cluster these student needs, which are important and unsatisfied, according to 4 clusters for a blended learning strategy. This was first the availability of learning materials and information, pragmatism of learning, and certainty within the learning process, encouragement and support. And all these was then translated into a technology solution according to a Moodle platform to support student learning and the process behind. And there we use this need-based approach, and especially the information about the student needs, to combine the outcome-driven innovation results from the ODI and the students' needs, which, for example, learning analytics from the Moodle platforms. And here we could do at a university level, increase the sense making, because the university now was able to better manage the innovation portfolio. So they could see better which e-learning projects were fitting the student needs. On the other side, they could also better handle scarce resources, especially financial and human resources who have to develop e-learning solution and blended learning solution. And in the end, they could better foster organizational change, because they can show from the ODI results and the, for example, the learning analytics, how students are using e-learning technologies, that something is impacting and certain technology are impactful and other not. And this they can better communicate to the university heads to proceed the digital change. Of course, this study have limitations. So it was a single case of a university. It was a technical university, so it's not so generalizable. And of course, we concentrated on students' need. On the other side, there can be also the so-called lecture needs, so of teachers, what are their needs? And that also brings us to future research, which can be a multi-case studies of using this method for other universities to compare this, to see other stakeholders and stakeholder needs, that are students, teachers, and maybe other stakeholders which have needs on university and of higher education. And at the end, we can also better segment our data to see, okay, between segments of faculties, of different kind of students, old students, young students, different backgrounds, or before the pandemic or after the pandemic. Yeah, that was it overall. If you have any questions, just let me know, or you can text.
Thank you, Sebastian. Thank you so much for presenting. Do we have time left?
You got 2.5 minutes. Over 2.5 minutes.
Okay, Sucheta has a question.
Yeah, thank you, Olga. Hi, Sebastian. Very good presentation indeed. So I have a couple of insights to render here, and you can either just take it as a feedback or as a question. So first thing is I would like to understand who the student is, because when we talk about student, we cannot just take them as one entity or as one unit. Students have their own socioeconomic, social status, and other constructs together that make them them. So when we talk about their satisfaction and sort of innovation that they are seeking for, it also varies. Like being an Indian student, an international student, I always have to be mindful that English is not my language. So there is a language barrier. And likewise, there are other students who have their own concerns. The innovation at times is also dependent upon the gender. So I would like to understand who those students were, and did you take into account the diversity that they had? That was one thing I wanted to touch upon. Yeah, I think I don't have the time to ask the other question, but that's it. Thank you.
So of course, for the population we interviewed, we took a broad population for the interviews. So we did like a waterfall segmentation here, that we took international students, students of every faculty, young and older students, and try to make it as broad as possible to identify as much outcome statement and especially student needs here as possible. And the later stage in the survey, we could survey like 10% already of the overall population of one of the largest universities of Germany. So it was nearly 3,800 students, and this was really broad. So we have a really generalizable sample of nearly each kind of student at our university. The only thing is here we have a technical university, which is more technical orientated, and that this might be a bias here towards these needs, of course. But this is for future research to see, okay, how we can define student needs, for example, according to different kind of faculties, different kind of origins, and to see how, for example, needs are different here. But this is very specific to our university where we did this. That's clear.
All right, well, thank you. Sounds like I hear timer. Thank you again so much, Sebastian, and thanks, Sucheta, and hopefully the conversation continues on through formal and informal channels until next Hicks, and always consider submitting new updated versions of your work or expanded now based on, it looks like, common interests. So feel free to reach out to each other, and I hope to see more papers we have, more sessions we have, and larger cohort we built, and we'll at one day they say ATLT is the biggest one, the biggest session ever. So let's hope it happens. Meanwhile, we have the last presentation. I know we're running a little bit over time, so if you have to step out, I know the time zone is different. Feel free to do it, and we'll share the recording. If not, we have 10 more minutes, so bear with us. And we have entrepreneurship education platform design, the relationships between autodidactic affordances and experiential learning needs, presented by Francesca, Kaveh, Vanessa, and Elijah.
Thank you, Olga. Greeting from sunny San Diego. I'm Kaveh Harry. I'm presenting this research on behalf of my undergraduate research students. And the title, as you see, is all about designing entrepreneurship education platforms. So the motivation behind the study was pretty simple. The literature falls short in explaining user experience for modern self-regulated learning platforms. By modern self-regulated learning platform, I mean platforms that they provide instruction without instructor. That means they teaching without teacher. So for design this platform, we use the case of entrepreneurship education platform because it's very common in this platform that the instruction, there is no formal instruction. So it's somehow informal, and users, most of the time the students, they are experimenting with their idea. They have access to the resources, but at the end of the day, the learning task is open-ended. So they can take it to any directions. For that study, we use the case of BZB platform and entrepreneurship education platform that designed mainly for middle school and high school students. It's available for college students as well. That gives students a chance to come up with an entrepreneurial idea, team up with other people on the platform. They go through the different stages. Each stage has a different task to complete. They have access to some learning materials and mentors if they are interested in that. At the end, they present their entrepreneurial proposals to the class, to the investors, to the community that they are working with. To conduct this study, we interview end users, about 120 end users. The exact number is in the paper, and ask them mainly three simple questions. What they want to achieve on the platform. So we understand, about the affordances, how they want to achieve that, what features they are interested to use, and why, to learn about their needs. And on top of that, we had follow-up interviews with developers to learn about, ideas behind different design scenario, the evolution of the platform, and some clarification about the users' reactions to the platform. Based on the classification of the responses, we identified 4 groups of affordances that we named them autodidactic affordances related to self-regulated learning, namely administration affordances, acquisition affordances, application affordances, and assessment affordances. Then we map these affordances with experiential learning needs. Those we already identified in experiential learning literature, and those that we learn that we could add to that list. Of course, sensorial, social, emotional experience, as you see in this diagram, are the first list of affordances that we identify, and needs, learning needs. These are the values that novice user, new users, they are very interested when they join the platform. How well designed is the platform, whether or not they can connect to the other learners, whether or not they can have fun, entertain on the platform. And after that, they become interested in temporal, cognitive, behavioral, and metacognitive experiences. For example, they want to know about their progress over time. They want to learn about their own learning journey. They want to see how their understanding about that project evolve over time, and whether or not they can take it to the real world and replicate it in a real setting. So we label that as metacognitive experiences. As you see in this model, we put all these concepts in a design framework to just guiding people who are going to design such platform for the new generation of the learners, what they need to consider. On the left hand, we had a typical self-regulated learning requirements: plan, prepare, learn, and reflect. And then based on that, we defined the group of features that need to be designed, what type of affordances should be enabled by these features, and then 2 group of experiences or needs that can be fulfilled or satisfied by these affordances. And there's somehow their timing within that. One thing was very interesting to study that learners, after, for example, a couple of weeks of using the platform, they lose their interest in their emotional or social or sensorial aspect of the platform and look at the other more critical aspect of the self-regulated learning. Overall, this study contribute to the platform design overall, especially for entrepreneurship education platform. However, it's generalizable to other platforms, other learning platforms that they want to implement modern self-regulated learning platforms with the true self-regulation components. I'm happy to answer your question and have your feedback on how we can take this study to the next step.
Great, thank you, Kaveh, so much.
My pleasure.